Hello, there is Impossible Creations, and in this video I will show you how you can set up your object to work with optimizers. Optimizers is a package which can switch different quality settings for any type of component in certain visibility conditions. In this video I will show you basics of setting up single object with optimizer component and describe how it's working. There I have prepared small scene with some objects and light. Light object have attached simple movement script, object with light component, and sphere mesh with glowing material, just to better visualize everything. Let's set up optimizer. I will add basic optimizer component to parent object. It automatically found light and mesh, but we won't focus only on light in this tutorial, so I remove mesh component from list. Let's configure base parameters. At first, let's set up max distance for visibility of this object. When object will exceed this distance, it will have applied cooled LOD settings, which in most cases it will be just deactivating object. We can use optimization method, and for now I recommend using effective and static methods. Untoggling cool if not C would make component work only on distance ranges, without detecting object visibility in camera view. And now we will focus on parameters for this detection. When the sphere will not be visible in camera view, then hidden LOD settings will be applied. In a minute I will show you this during play mode. For now, detection sphere radius automatically adjusted itself to fit light range. But for this tutorial purposes, we will change this radius to be much smaller, so we will see what it's doing. Of course, in game you need to keep this range bigger to make quality changes not noticeable. Then we have adjust gizmos visibility. If we don't need them, we can turn it off. Then list of objects to be optimized, and help buttons to automatically find other components, or drag and drop needed ones. And now the most important section. There we will decide what will happen to the components. We can define how many quality settings we want to use. We can activate smooth transitioning between LOD settings, or choose to use shared settings, which I will describe in next tutorial video. Let's focus on distance ranges. On scene gizmos, we can see ranges for different LOD settings. Each of them have own indication color, and by clicking on them you will clearly see in which camera positions settings will be triggered. For tutorial purposes I will change these ranges to be very small, so you will easily see logics of this system. First LOD setting, called nearest, is restoring settings from initial object's parameters. In next LOD settings we can change these parameters, and we change them in percentage manner. So if I change here value for intensity and range to be about 0.85, then when camera enters this LOD range, intensity and range of this object will be 85% of initial values. I will change more of these values just to visualize everything in play mode. Changing intensity of light is not doing much to the performance, but it can help smoothing out transitions between different quality settings. Let's enter play mode and see what it's doing. Inside the inspector window you have real-time preview of what's going on with a component. So when we go through different LOD settings, you see that light parameters are changing. And as I described before, parameters are changed in percentage manner. So when game started, light range was 10, and now it was multiplied by this value. Now I will change intensity to be very small, and then you see what it's doing. Now I will change intensity back to higher value but smaller range value. So now when I go further, then you see that 10 value is multiplied by this. But now let's talk about true optimization. Shadows can take a lot of performance from your project. With optimizers you can switch to hard shadows or disable them, and change light importance. Unfortunately, light importance settings naming is different in inspector window and different in coding. That's why these parameters have different names inside optimizers. But I will fix it in next updates. We will make the settings to change smooth with transitions, but in a minute. Now we will focus on detection sphere. You probably will see it like in low FPS, but you can notice that it's only applied to the sphere because its position don't need to be updated every frame. So if any part of the sphere is visible in camera view, object will be set as visible. When camera will look away, then hidden LOD settings will be applied. Let's look down, and you see. Now we can define from which LOD settings object should be cooled when we don't see it. But let's say we don't want to cool object when we don't see it and when it's very near to us. Then we untoggle hidden LOD settings to not be same as cooled. For now, for example, let's disable just shadows when we don't look at them and first LOD range. And as you see, shadows are disappearing. Now let's go to second LOD range and look away, then object is cooled. We can adjust this with slider, so now when we look away in second LOD range, hidden LOD is applied instead of cooled. And the same logics for the rest. Now let's make these quality changes to be smooth. And we will do this with transition in feature. We can define how long should take transition, half of a second will be alright. Let me set up inspector windows, so we will see optimizer and light component in the same time. Okay, and let's go further. As you saw, parameters changed smoothly. And now shadows faded, and light importance changed to not important, so vertex light. Difference between important and not important light is very big, that's why I'm changing intensity to be lower to make this change less noticeable. Let's see trees count and move a bit more. So when we fade shadows, trees count changed drastically. Let's move quickly to first LOD, and everything works smoothly. Shadows inside the game engine is very big deal. You can check it by yourself. More polygons on scene than shadows cost much more. Defining max distance in quality settings for them, it's often not enough. With optimizers you have possibility to customize this for each light in the scene. Alright, final step. Let's create prefab. With creating prefabs I had a lot of troubles with Unity, because each version of Unity have different logics of working with sub-assets of prefabs, and to make system work I had to use scriptable objects, which theoretically must be saved in project as files. To make it more comfortable, I'm saving these files inside prefab as sub-assets. You can save these settings as files inside project by using shared settings. It's more safe way to work with optimizers, but I will talk more about it in next video. Creating prefab file without shared settings sometimes can cause some troubles. For example, settings made in scene can be resetted, so be sure to always check it. Then can be logs inside console to warn you that something can be wrong, but in this case everything's saved correctly, as you see. Alright, that's all for this tutorial. I hope it was helpful for you. Subscribe if you want more. Hit bell for notifications about new videos. Thank you for watching and see you next time. Bye bye.